Hi everyone, welcome to week 4 of our Programming for Data Science course. This week, we'll dive into functions, parameters, recursion, and modules, some of the most foundational concepts in Python programming. By the end of today's session, you'll be able to 1. Define and use functions to write reusable code. 2. Work with function parameters and return values. 3. Understand recursive functions and when to use them. 4. Import and use Python modules to enhance your programs. Let's start by learning how to define functions, which form the building blocks of reusable and modular code. Let's start by understanding what a function is. A function is a reusable block of code designed to perform a specific task. Functions help you reduce redundancy, write code once and use it multiple times, improve code readability, organize your logic into smaller, manageable chunks, simplify debugging, isolate specific parts of your program into functions, making it easier to test and troubleshoot. Functions are an essential tool for writing clean, efficient Python code, and they'll become invaluable as your projects grow in complexity. The syntax for defining a function in Python is straightforward. Def function name parameters, code block return value. Here's what each part means. Def. This keyword tells Python you're defining a function. Function name. Use a descriptive name that reflects what the function does. Parameters, inputs that customize the function's behavior, optional. Return, outputs a result back to the caller, optional. For example, here's a simple function that prints a greeting. Def greet print hello world. Let's see how we define and call a function in Python. Def greet print hello world, greet, this calls the function. The output is hello world. Notice how calling greet reuses the same code. Functions make it easy to organize your program into reusable parts. Why are functions so important? 1. Reusability. You can define a function once and use it multiple times. 2. Modularity. Break your program into smaller, more manageable parts. 3. Debugging. Test and debug functions independently, making troubleshooting simpler. These benefits make functions indispensable for efficient and scalable programming. Functions often need inputs to work with. These inputs are called parameters. Here's an example. Def greet name, print hello name, greet Alice. When you call greet Alice, the function uses the input Alice to customize its behavior. There are two main types of parameters, positional parameters, matched by their position in the function call. Def add a b, return a plus b, print add 35, output 8. Keyword parameters, matched by their names. These are more flexible and allow default values. Def greet name, greeting hello, greeting name, greet name Alice, greeting hi. Output, hi Alice. Default parameters provide fallback values. For example, def greet name world, print hello name, greet. Output, hello world. If you don't pass a value for name, it defaults to world. This is useful for creating flexible functions. Functions can send results back to the caller using the return statement. Example, def square x, return x result equals square 4, print result. Output 16. Return values make functions more powerful by allowing you to compute and reuse results. Python functions can return multiple values using tuples. Example, def get stats numbers, return min numbers, max numbers, sum numbers, len numbers. Print get stats 1, 2 output. This is great for returning multiple pieces of related information. Recursion is when a function calls itself. It's particularly useful for problems that can be broken into smaller subproblems, such as calculating factorials or Fibonacci numbers. Every recursive function has two key components. 1. Base case, the condition that stops the recursion. 2. Recursive case, the part where the function calls itself with a smaller input. Here's an example of a recursive function to calculate a factorial. Def factorial n, if n equals 1, base case return 1, return factorial minus 1. Recursive case print factorial 5 output 120. Each recursive call reduces the problem size until it reaches the base case. Recursion and iteration can often solve the same problem, but they have trade-offs. Recursive solutions, cleaner and more intuitive for certain problems, but may cause stack overflow for deep recursion. Iterative solutions, more memory efficient and easier to debug for larger inputs. 1. Always define a clear base case to prevent infinite recursion. 2. Avoid deep recursion when possible to prevent stack overflow. 3. Use recursion for problems that are naturally recursive, such as tree traversal. Modules are files containing Python code that you can reuse in other programs. There are two types: built-in modules, pre-installed with Python, e.g. math, random; custom modules, created by users. Here's how to use a built-in module. Import math_print.16, or import specific functions from math, import print 25, output 5.0. You can create your own module by saving Python functions in a .py file. For example, create mymodule.py, def greet name, return f hello name, then use it in another script. Import mymodule print mymodule.greet Alice. Import imports the entire module. From import specific parts of a module. As provides an alias for a module, import math as m, print m, output. Here are some commonly used Python modules. 1 math for mathematical functions, 2 random for random number generation, 3 os for file handling and operating system tasks, 4 sys for system-specific parameters and functions, 5 datetime for date and time manipulation. 1. Import only what you need to avoid clutter. 2. Use descriptive aliases for clarity. 3. Organize imports at the beginning of your script. Today you learned 1. How to define and use functions. 2. How to work with parameters and return values. 3. The basics of recursion and its applications. 4. How to import and use Python modules. Next steps: practice writing functions and explore Python's built-in modules like math, random, and datetime. Thank you and happy coding.